we have the next tab is the shader settings, where you can specify how your particles will be shaded, whether the light will be scattered in all directions, the same, which is the isotropic one. The funk shader is kind of fakey because we're rendering volumetrically, but we're pretending that each particle is on a surface. So in the volume, if you have specular highlight like here, and it's semi-transparent, the specular highlight actually penetrates the volume, and each particle down to the core of the object is going to cast create a highlight. It creates very interesting results, but they're not physically correct. We added this mode mostly for people that want to simulate hard bodies that are completely opaque and you don't really see much in the volume, but you want it to look like metallic. And in this case, this dragon was actually rendered using those settings, so we have the specular highlights there. We also have the Hennig-Greenstein and the Schlick, which basically control the scattering of light based on the angle between the light and the camera. So if you're moving around the object, it's going to change how much light is going to end up in the camera. And we have the Kajiya-Kai, which is a simple hair shader, and the Marshna, which is a complex hair shader. It actually was used on King Kong. Was a development that was then implemented by Weta Digital for the King Kong shader. So we couldn't call it King Kong because we have Kajiya-Kai that's shortest to KK, so it would be too many KKs here. The real paper is actually it's called the Marshna model. So we have provided those shaders, but most of the time you barely need them in Kryktor unless you're rendering here, that is coming from somewhere else. If you watch the videos from NAB, I had an example where I showed some hair rendering, and you can go and check out that. I don't want to repeat that information. What I'm going to talk about quickly now is the log. Logging is on by default, and as we already saw, it actually writes to the log. I'm going to actually, switch to a new scene. I'll create quickly something there, like as usual, Kryktor, PRT volume with the default light. So that's everything that you need in order to create your Kryktor test scene in order to render. If I switch this one to error, since currently we don't expect any errors to happen because everything is cool, if I render this, I get some sphere there and nothing really gets logged. And this is approximately the case with also the warnings. Warnings are non-fatal errors. And the progress is being printed whenever you are repopulating something. So if I go here, for example, and say, okay, I'll be using about size of 4 for the particles, so it's very few particles. But on top of that, I'm going to add a repopulation tag and request that with a size of 4, I want to distribute new particles around these particles. This will repopulate the particles at render time, and you see that the progress is being printed. So it said, yeah, I am computing new particles to add around those, and this actually filled the voxel grid around them, and it's kind of noisy, but you'll see that it actually is printing something in the progress case. I'll disable this one, so we get rid of the slowdown from the repopulation, and I'll switch this one now to stats. This is what you normally get by default. You're getting statistics about how long the individual steps took. How long to create the particles, to load them into memory, how many particles went into memory, how much memory was used, the lighting pass, sorting, and drawing into attenuation buffers, and then the sorting to the camera and drawing into the camera, and the total time 0.929 seconds, 0.3 seconds. So if I switch to the last mode, which is the debug mode, then it's going to give me a little bit more information on top of that, and that information in the beginning is very useful. It tells you about the channels that were allocated. Currently, we're using only position, color, lighting, and density. This is almost the minimum. Actually, we can render without lighting, but it makes little sense because then it will be black. We'll ignore the scene lights, and if I render now, no particles will be visible here. They will be visible only in the alpha, but they are pretty much black. And of course, if I'm rendering on a blue background, then I might see them. Okay, here we are, and we render again. We'll see black particles on blue background, and now we're actually interesting. It actually still allocated the lighting channel. I think that's a bug. Ignoring the lighting settings should actually disable that channel. So we'll log that one to fix it for the next build. But if I start enabling other channels like use emission and use absorption and use this and that and continue rendering, I'll enable again the drawing so I get white particles. Here you'll start seeing that additional channels are being added. Emission, absorption, lighting, color, position, and density are now there. And instead of using 1 megabyte of memory, now we're using 2 megabytes of memory. We added too many channels. Well, if you're rendering millions of particles, that can be a problem because it might be rendering a billion particles, and adding an additional channel might mean you're running out of memory. So I have to keep in mind what channels are active at any time, and there are many channels that you can enable, also for shaders. If you want to control per particle what the specular level and specular power are, I showed it also at the NAB demo. This will also add additional channels and additional bytes per particle, but if you're not setting them using tags or textures, it's a bad idea to enable them because that will add more to your memory layout. We're still using 2 megabytes because we don't have that many particles, but we don't really want to add additional. Actually, we are not in funk mode. Now, if we would do that, you'll see that we now also have the normal because needed for the funk mode, and we have also the specular power and specular level, and still using 2 megabytes because very few particles, but the channels are a lot more. Keep that in mind. Okay, that's about the logging, and you can also send the logging to a file if you want to keep it for like benchmark purposes or for whatever reason. It's kind of useful. I'll keep the debugging mode here. Licensing. Licensing turned out to be the most difficult feature of Krikator. Most people have the initial problems with Krikator, just getting it to run, getting the license working. So let me tell you a couple of words about it. There are two general types of licenses that we issue. You can use a license server to distribute floating licenses. That means you can have multiple machines and only one copy of Krikator, and you can launch Cinema 4D, try to render on one machine. It will pull a license if there is one. If you open another computer, open Cinema 4D, and try to render there with Krikator while the other one is rendering, you're not going to get a license because it's only one there. But if you have two, a new license will be sent to that machine until you close Cinema 4D, then the license will be returned. So you can have an office with 10 people working and only 2 licenses, and they can share them. So 2 people at a time can use the product, and the other 8 will have to wait for somebody to close Cinema 4D to release a license. This is very good when you have multiple machines, but if you have only one, especially if it's a laptop and you want to bring it with yourself, you might want it node locked. So it's, in that case, it's just text, like a license file that we sent you is being pointed at using the license file path. You just pick that file, put it somewhere on your desktop, pick it, and then it runs. And it's only on that machine, and you cannot use that license anywhere else. When you're using the floating license, you have to set up a license server application, which is provided by Flexera. It's called FlexNet, or also known as FlexLM. That's what Maya, for example, uses for licensing, and several other products. Pretty much all ThinkBox products use that, and Deadline also. So that's a lot more work to actually set it up, but you can have that license server working on one machine in your local network, or even somewhere in a different city or on a different continent, and you can have a VPN connection over the internet connected to that server and getting your license. We have customers that have the license server in Los Angeles and workers in Berlin, and they're pulling licenses for there. And other people in Vancouver from here, for example, also are getting that. I'm getting my licenses for Cinema 4D and most of the plugins there from Winnipeg, even though I'm in Vancouver. But that requires a little bit more setup. All you need to provide us with is the MAC address, that's the Ethernet card, like physical address, and the name of the machine where the license server will be running. You can use the IP, but normally you just give it the host name. Your computer tries to connect to that machine with that name, finds it on the network, asks, do you have the license for me, and gets it. If you are running behind the firewall, you have to also specify a port if necessary. But that's for IT people. Most of the time, I would suggest that you probably want to run with an node-locked license unless you want to have multiple licenses or have many machines that are in the same network. The final tab in the Krakatoa render dialog is the Tools tab, and this basically is used to produce a special channel, which or special kind of channel from any existing channel. Basically, it lets you create a sticky channel that is taken at birth time of the particle, and then it sticks throughout the life of the particle, remains with the same value. If you watch the videos from the third day from the NAD presentations, you'll see a lot more in-depth information about how this is used. Basically, we had an example, I think I have it somewhere here, which was the logo reveal. Here it is. And if you haven't seen the video, I can probably show you the video. Let me see if I can find it though. Yes, I have it. I actually have a large version and a small version. I'll play the small version if my QuickTime player wants to open, of course. It has to think a little bit. Here it is. So basically, this was simulated in RealFlow, and when it was simulated in RealFlow, this camera projection of texture wasn't on top of the particles. If I play it back, you see that the RealFlow is blowing the particles away, revealing the Krakatoa logo underneath. But the colors that are being camera projected onto the particles are actually sticking to the particles, and you can see the blue going away with each particle. It's always there, even though the color that is on the particle is taken from where the particle was born. That's what we used this tool for. Basically, we took the setup, we took the original bin files that were saved out of RealFlow, and we passed them through this setup where we said, take the position channel at birth time of the particle, and write a new birth position channel with that value on each frame, and it tracks the particles by their ID channel and creates exactly the same sequence, but with the additional birth position channel in this case. But I can make a channel with any name here, really. I can output it to a custom channel and give it any name. I can call it test, and it will also work. And then when I'm using camera projection, I can use this new sticky channel to request the color from the projection point where the particle was born instead of where the particle currently is, and that gives you that amazing effect of destroying objects while keeping the color stuck to the particle. Go and watch those videos from NAD, they're pretty cool, and you'll see a little bit more about it. We had to add this tool specifically because in this case, RealFlow didn't have a good way to create that sticky channel for us, and the simulation was already done. We decided we're not going to ship Krakatoa for Cinema 4D without actually having an easy way to create this kind of effect, because it's very, very useful for commercials and visual effects. So this is the first time this tool appears. We'll probably port it to the other implementations of Krakatoa in the future, but that's a first here.